Okay, great. I'll push in. Okay, so why is it going back? So our idea was to actually set up a field course to replicate an actual field course with tasks and activities. And we decided to go to the Isle of Elba, which is a small island off the west coast of Italy. Our course was going to be a 3-day course, as well as a final assignment. Each day would go from 10 a.m. to 4 p.m. with a 1-hour lunchtime and a short assignment every evening, which is meant to last 1 hour. The objective is for students to understand the geology of the Eastern Peninsula of the Isle of Elba, to refresh basic geological skills, techniques, and them in a virtual setting, and provide insights into quantitative approaches to geology and exploration. Each day will have a unique focus. One will be on local lithologies, one will be on structural geology, and one in economic geology. We think this makes it transferable because this provides a framework for us to drag and drop this idea into other locations. Essentially, for our field trips to work, we just need a location with good lithologies, good geology, good structural geology, and good economic geology. Students will be able to take advantage of a plethora of software, and students will leave an appreciation for the applications of modern technology to economic geology. I don't know why it's doing this. Independent learning and problem solving will be encouraged. Attitudes that they'll foster is they'll increase their confidence in their geological ability and have an appreciation of the use of data in problem solving and a quantitative approach. We chose Elba for incredibly diverse geology, and it provides a holistic overview of a broad range of topics of study. Therefore, we can teach a plethora of things and into great detail. And as you can see, is a stratigraphic column showing the diverse set of rock units, metamorphic, igneous, and sedimentary. It also has thrusting as well as normal faulting and the convergent and extensional regime. Go back again. And abundant economic deposits. So day one, we're going to look at the local lithologies. We're going to, task one, we're going to have an overview of the local geology through remote sensing. So there's a road cutting that goes directly through the area, going through all the lithologies that we wish to look at. And we'll look at that through remote sensing. Google Maps and Street View provides a great way to do this. However, also the field instructors could go there beforehand and take photos.
To use as a photogrammetry, that is. So we wanted to have a 3D image of the and high resolution of the outcrops for the students to,
That's fine. And for task 2 is in a similar way. We'll look at 3D photogrammetry of hand specimens of minerals and rocks. We've looked online for free software in which you can take a 3D photo that can be rotated for a hand specimen. We've looked at Meshroom.
Yes, we use Meshroom to create them. And we decided on an online environment called 3dviewer.net, I think, which is quite easy to just show anything in, and it saves the students having to download anything onto their own computers.
And therefore, they can look at hand specimens online, virtually. And then that evening, we'll look at thin section analysis. So we've looked online and saw that you can actually look at thin sections online virtually, rotating the thin sections just so pleochroism. The website we have there shows an example website where that has been done. It's been coded on HTML, which means we're incredibly confident it could be coded into Python.
Yes, so we were actually able to, because it was in HTML, we were actually able to look into the code behind it, and it turns out to be absolutely trivial code, so it could be very easily reproduced by anyone who has some coding skill.
So the second day, we'll look at the structural geology of the area. The first thing we do, we're going to look at large-scale faulting and geomorphology. And we can look at the geomorphology on Google Earth and on large-scale photographs, such as the one you can see in the PowerPoint. The task 2 will be interpreting stress through microstructures. Again, we'll look at virtual thin sections, and we'll be looking at identifying deformational fabrics, and microstructures, sorry. And the students will be tasked in making interpretations based upon those observations. That evening, we'll ask the students to plot StereoNets based on data that we will give them. This is using the program StereoNet 11. And we'll expect students to identify faults, and for these faults, identify the strike, dip, and sigma 1 orientations based on the data that we've given them.
Just to an additional bit of context here, for the final exercise, we intend to prepare a model, a 3D model of some characteristic structure in the area, such as a fold or something similar, in a program like Leapfrog or Georeka, that on a license for used by the field trip leaders, which can then be handed out to students to use in the free viewer version of that software. And then we intend to have the students take measurements off of that using a slicing plane, and then feed those into StereoNet 11 by hand.
So the third day, we'll look at economic geology. The first thing we'll do, we're going to have a look at a lecture which will detail all the economic deposits in the area, their formation processes, basically telling the students how they formed. Task 2 will be another virtual hand specimen, but this will be for the ore minerals and the ore-bearing rocks. This will be, again, on a software such as Meshroom or Autodesk 123D.
The second one is paid for, but we expect it, as a result, to be a bit more sophisticated.
And task 3 will be a structural exercise synthesis. Students will be provided with a 3D model of a large iron quarry with photogrammetry software such as Pix4D or LiDAR. We'll also show them drone footage of that quarry. Then they'll be given large maps of the wider area. Students will analyze these maps for lithologies and structures, especially the ones we've seen earlier in the course.
And crucially, they will be required to place the various samples and locations they'd seen on the map before.
And later that day, we'll teach them how to use QGIS. We're going to give them a few layer files and some georeferenced topographic maps, and ask our students to build a QGIS map based upon the data we've given them. Assignments and evaluations. They'll be assessed on all the assignments that they were given over the course, plus a final assignment that we expect them to write a 1,000-word essay on the geology of the area. We'll provide them with a reading list. Essay topics will focus on the lithology, structural economic geology, i.e. one of the days which we just studied, and they'll have a week to complete this assignment. We think it's a very sustainable project, as there's no, well, as in any virtual field trip, there's no bringing students to the area, no driving around, but also we think it's particularly sustainable because we only use one hand specimen for all of our hand samples and all of our thin sections.
But one of each place. And crucially, it also means once recorded, the course can be given an infinite number of times without having to go out there again.
Yes. Thank you.